We are going to do learning target 2 for lesson 1, where we're going to write equations for parabolas, most likely horizontal parabolas. Uh, we have a couple pieces of information. We know that the focus is at 2, 3, 0, so it's on the x-axis, and then the vertex is at the origin. So if we need to write an equation for this, maybe first it would help to just kind of see what's going on here. And so, if I've got 1 here, well, the focus is at 2/3, which would be right about there. And then the vertex is right here at 0, 0. And so if the focus is right here, well, that means I got a pretty good idea that the parabola, whatever it's going to look like, is going to be like this. And so that gives me an idea that, okay, yep, it's going to be horizontal, it's going to open up this way, and so I know some things about it. I know that if we use that equation that we did for learning target 1, we would be using y squared, since it's horizontal, equals 4 times p times x. And remember, p is the distance from the focus to the vertex. So if the vertex is at the origin, it means, well, this is 2/3 from the origin. And so I can go ahead and fill this in. I got y squared equals 4 times 2/3 times x. And, well, 4 times 2/3 would be 8/3 x. Now I've got y squared equals 8/3 x. And, well, that is a legitimate equation for this parabola. Now, obviously, we don't love this one. It's not in necessarily in a format that's easy to use, but it does work. All right, so this one, just a little bit more complex. Here we've got a vertical axis of symmetry. So that means it's going to wind up being so the vertex is at the origin, and a vertical axis of symmetry means it's a vertical parabola, and then it goes through the point -2 and then 12. 1, 2, 3, 4, 5, 6. I'll go by 2's here, but I'll go by 1's here. So one of the points is right here, but the vertex is still at the origin. So I do know that it's going to be symmetric around here. And so how could I write an equation for this parabola, where I've got -2, 12 as one of the points? Well, because it's a vertical one, I can use the other equation, x squared equals 4py. And this being the case, well, I don't exactly know what the focus is, so I can't really put in a p right now, but that's what ultimately I would like. What I can do is I can plug in this for x, and I can plug in this for y, and just solve for p that way. So I have -2 squared equals 4 times p times y, which is 12. Well, this will give me 4 equals 4p times 12. 4 times 12 would be 48. And if I divide both sides by 48, I get p equals 1/12. Okay, that's great. I can go ahead and plug this back into this guy right here. So I get x squared equals 4 times 1/12 times y. Well, 4 times 1/12, that would be 1/3 y equals x squared. And again, this would be perfectly legitimate. It's about the same form as that one. Although, when it's a vertical parabola, it's a whole lot nicer if we solve for y. So if I multiply both sides by 3, the inverse, I could just get y equals 3x squared. And you can see that that actually fits very well with what we have here. All right, moving on. It says write an equation for the parabola with a vertex at 1, 3. So here's our first one with a shift. So vertex is here at 1, 3. The focus is at -1, +3. And so again, that means that we got a pretty good idea that it's going to open up this way, if that's where the focus is. So here's how this is going to go. We're going to use the same formula. We know it's a horizontal parabola, and so we're going to use the y squared equals 4px. Except this time with a shift, we're going to apply the h and the k. And so I got y minus k squared equals 4 times p times x minus h squared. Okay, so here's another couple of things. Number one, if this is the vertex, and this is the focus, the distance between them, that's the p-value, well, that would be positive 2. But notice that we're actually kind of going this way. So in a weird sense, it's like saying p is negative 2. So p equals negative 2. You can't have a negative distance, but we are going left. And so you can see that if I plug in negative 2, that gets me the negative 8, or a negative value here that is going to make it flip and open up to the left. All right, so I've got that. I got y minus k squared equals negative 8 times x minus h squared. And, well, all I really need now is an h and a k value. Well, I'm going to get that from here, and you guys remember how to do that. We're just going to plug those in for x and y, and that will leave us with negative 8 x minus 1 squared, and then y minus k squared. All right, that's our equation. And you can see we do know that we've got this is the vertex. It's going to be opening up this way. It's going to have kind of not a slope of 8, but it's going to be fairly severely narrow. So up 1, 1, 2, 3, 4, 5, 6, 7, 8. Then we have the symmetric point over here, and there we go. We're done. And that's how that one gets graphed. All right, let's see, taking a look at the last one here, we've got a little problem-solving question. You've got this radio telescope, and it's got a parabolic dish with a diameter of 210 and a depth of 32. So we're going to put this right here as the origin, and we want to know a couple things. Determine an equation that models this cross-section. So we got the origin with the vertex, and so how's that going to look? Well, let's go ahead and put this on a rough sketch. We're going to say that this right here is 0, 0, and then if this is 210 feet across, and this is right in the middle, that means I've got 105 to the left and 105 to the right, and the y value would be 32. So I got 105, comma 32, and I've got negative 105, comma 32. Okay, so I got a few points here. It's going to look like this. And so what do we want? We want an equation for this. And so this is a vertical parabola, so I'm going to go ahead and use the x squared equals 4 times p times y. We just need to figure out what p is, and we can do that just by plugging in coordinates for x and y. I'm probably going to pick this one since they're positive, not that it really matters. So I've got 105 squared equals 4 times p times y, which is 32. We get 4 times 32, which would be 128, and 105 squared is 11,025. So we got 11,025 equals p times 128. Now I can very easily solve for p, and I get p is about 86.1. And so when I put this into my equation, I wind up with x squared equals 4 times 86.1, which would be 344.5 times y. All right, so there is my equation for this parabola. And then it says the receiver must be placed, so here's the receiver, must be placed at the focus of the parabola. How far from the vertex of the parabolic dish should the receiver be located? Well, that distance from the focus to the vertex is the p-value, and we just solve for that. So we just very simply say 86.1. All right, there it is. That's the end of lesson 1.